Hello boys and girls, this is Mr. So again. Welcome back for another lesson of biology. Today we are going through lesson 34 of chapter 15, the light-sensitive cells in the retina. That means the photoreceptors. Before you start watching the video, remember to like and subscribe my channel and also share the video to your classmates. Let's start. Exactly how do we see? We need our eyes and also we need your brain. Have you ever heard the news that a person get hit from the back of the head, maybe by a ball or maybe by a stick, and then afterwards he or she lost his vision? He is blind afterwards. Do you know why? In order to know why, after hit by a ball at the back of your head, you will be blind, we have to understand the process of how we see. First of all, the light ray from the object that we are seeing, the light ray will be refracted, 折射, and then focused, 聚焦 onto our retina. The image formed on our retina, they are real. That means it can be formed on a surface. It is also upside down, 上下調轉, laterally inverted, 左右調轉, and smaller than the real object. The image formed on the retina is detected by the photoreceptors, which will then produce and send nerve impulse. The nerve impulse will then be transmitted to the visual center in the brain through the optic nerves. And where do you find the visual center? You can find it at the back side of the brain. In the visual center, the nerve impulse, they are interpreted, 解讀啦, to give an upright image of the object. Take a look at news from Taiwan in the year 2014. 女童嬉戲後腦撞地下，3日後雙眼半盲。小朋友喺學校點解會玩到幾乎失明呢？新北市有一名小學1年級嘅女童，落堂之後同同學玩呢個互相推撞嘅遊戲，結果呢唔小心俾人推咗落地下，後腦撞地。當下冇異狀，但返屋企3日之後呢，女童開始頭痛、嘔吐，送院檢查發現原來女童嘅頭骨入邊有出血，血塊呢壓到視覺神經，導致佢嘅眼呢幾乎要看不見啦。This is the reason why, if you get hit from the head, maybe there is some injuries on your optic nerves, or there might be even injuries on the back side of your head, which is the injury on your visual center. This is going to affect your vision, and you might lose your sight and become blind. Let's take a look at the light-sensitive cells. There are two types of light-sensitive cells, the photoreceptor. The first type, rod cells. They help to give black and white visions. The other types, cone cells, they help to give the color vision. Both of them, they detect the light, and then they send the nerve impulse to the brain for interpretation, 解讀啦. So you can see these are the rod cells and these are the cone cells. They are slightly different in the shape and they will produce nerve impulse and send it through the optic nerves to the brain. And the shape of the cone cells and rod cells are shown. This is the cone cells. This is the rod cells. For the rod cells, they are for black and white vision. They contain the pigment, 色素 called the visual purple, and they are extremely sensitive in low light intensity. So they are for the vision in dim light, in the very dark. Where do you find the rod cells in your retina? You can find it throughout the all surface of retina, except the yellow spot and except the blind spot. They are for black and white vision. Let's take a look at the case when you have something wrong with your rod cells for black and white vision. This is a normal healthy person. This is a person with very, very weak rod cells. What happens? We call this night blindness, 夜盲症. If you have very little visual purple, that means the pigment for black and white vision, you are going to have the disease called the night blindness. In Chinese, 夜盲症. So how do you fix it? How do you stop from having such a disease? You can try to eat more vitamin A, which is good for your eye, which is good for forming the visual purple, or you can eat more carotene, carrot, 胡蘿蔔素, which will be converted in the liver to vitamin A. Also helps in making more visual purple for black and white vision in the rod cells. Cone cells, on the other hand, they are sensitive to high light intensity. So they work best in the bright light and they are for color vision. Where do you find the cone cells? You can find them concentrated at the yellow spot. That means in a great amount in the yellow spot, grouping together like this. And there are 3 types of cone cells. You have the red cone cells, green cone cells, and the blue cone cells. 3 different types. And on the other space of the retina, you can also find the cone cells, but the concentration is really, really low. Alright, really low. To help you better remember the 3 different cone cells in your eye, the red, the green, and the blue cone cells, remember this TV buddy, alright? 仲請唔請人啊? Alright, so remember this, you have 3 different cone cells and it is exactly the same color as the TVB logo. Each cone cell has a range of color detection and light detection. So with all 3 different cone cells, the red, the green, and the blue cone cells, it gives a very wide range of color perception, different color perceived. This table shows you the difference between the rod cells and the cone cells. For their sensitivity to the light intensity, rod cells, they work in very dim light, black and white, while for the cone cells, they work in the bright light. And then for the vision, rod cells, black and white, cone cells, you have 3 types of cone cells. You have the red, you have the green, you have the blue, just like the color of the TV buddy. And then the distribution, how are they located on the retina? The rod cells, you can find them throughout the retina. While for the cone cells, you can find them a lot concentrated at the yellow spot, low amount in the periphery, 周圍啊，周邊. But you cannot find you cannot find any rod cells at the yellow spot or the blind spot. For the cone cells, you cannot find them in the blind spot. So anyway, blind spot always does not have any photoreceptors. Remember that. Here you go. This is the blind spot. This is where the optic nerve leaves the eyeball. On top of the blind spot, because there are many blood vessels and many nerve fibers, there is no photoreceptors. Therefore, there is no nerve impulse generation, even though the light shines on it. And therefore, the image formed on the blind spot cannot be seen, cannot be interpreted by our brain. Alright, let's take a look at the question to check your understanding. Will the image be formed on the blind spot? Will the light shine on the blind spot? Of course, yes. Light or image, they can be formed on the blind spot, but the problem is you cannot see them because there is no photoreceptors on the blind spot to detect and produce the nerve impulse. There is no photoreceptors, so no detection, no production of nerve impulse, no transmission to the brain visual center. This is the reason why there is image on the blind spot, but you just cannot detect it. If you want to do a blind spot test, it's very simple. Let's do it together. Alright, so place your screen of this PowerPoint of this YouTube in an arm length in the horizontal level. And then do the following. Close your left eye and stare at the star on the bottom of this page with your right eye. After that, slowly move yourself towards the screen, and at certain distance, at certain point, you will find that the black circle on the right disappeared. And this is the time when the light from the black circle fall onto your blind spot. You just cannot detect it, so it seems disappeared. But if you move closer to the screen again, or you move further away from the screen, you can see it back because the light no longer fall on the blind spot. Please go to your textbook, page 15, to do a MCQ question 1. At the last part of this video, I would like you to take a look at the graph below. It shows you the relative abundance of light-sensitive cells on the surface of the retina, on different spots on the surface of the retina. Let's take a look. For the cone cells, they are the graph in red. You can find this is the cone cells because you can find a great amount of cone cells in the center of the retina. And this center is the yellow spot, which is having only cone cells but no rod cells. And let's take a look at the graph for the rod cells in blue. Alright, this is the graph for the rod cells in blue. You can find them having more amount in the periphery, 邊緣地區, and you cannot find any rod cells in the yellow spot. None. No rod cells in the yellow spot. So this rod cells is the graph in blue. And for the last part I want you to know is, for the blind spot over here, you cannot find any photoreceptors. Not the rod cells, not the cone cells. This is the blind spot, no photoreceptors. Let's go to your textbook, page 15, to do the MCQ question 2. That's it for the lesson about the photoreceptors, cone cells, and rod cells. I will see you in the next video. Bye-bye.